So I want to go through, make sure we see all the different capabilities. So uh, um, let's see, was it Daniela from Milano? No, that's Monterey. From Milano, there was who sent the nice note about the big project this week? Um, Dan Ingracia. So Danielle, are you connected?
Yes.
Yeah, it
Hi.
looks like you did a very interesting week's work this week.
Oh, thank you.
So talk through what you did.
Yes. As we see in
Sorry, can
last
you come
week's.
closer to the microphone?
Okay. As you know, I made the satshakit. So as first experiment, I
So
tried.
sorry, Daniela, two things. Talk a little slower for all the languages around the world,
Okay, sorry.
and remind everybody what Sasha Kit is.
Yes, satshakit is Arduino compatible board, and it's very close to Arduino because it has the same frequency, and it's possible to program it directly from an FTDI interface and
Okay.
with the Arduino ID. Okay. So this week I further experiment with satshakit. So I made some improvements and also some other boards that supports satshakit, like this power board.
Okay.
This power board is useful because you can power different devices at different voltages, like 5 volts and 3.3 volts. And you can use a 9 volts battery or a 12 volts battery and so on, because it has two voltage regulators. So
Okay.
this is a new version of satshakit. I called it modular multi-core satshakit.
Okay.
Basically, it has very few modifications. It has
And so
only
pause for a minute. It looks like you're making all your boards now with the fiber laser. You continue to be happy with that?
yes, because I feel that the fiberglass is it's possible to engrave more the fiberglass, so you will not have problems between traces. Because we sometimes had problems with resin boards FR1 sheets. So I prefer to use fiberglass instead of FR4 sheets instead of FR1 sheets. Okay, so this is one of the first boards modular. This is a dual layer FR4. So I managed to do this by putting the extra pins, the holes at the center of the Y axis.
So sorry, I'm back now. I had my 10-minute drop through the phone, so I'm catching up. I had asked about the laser. Oh wait, see.
Okay,
Let
so
me.
the first you can see some videos about this modular version. You can put a board on another, and they are connected by VCC, GND, and also E2C.
So
So
pause on this. I really like it. When you say it's a five-core system,
yes,
it's important
it's
to be clear that it is a five-core system. that
okay.
that four-core processor is non-trivial. You really do have four cores running doing four processes. Even if there's no global network, just making an architecture for multiprocessor communication is great. I really like that.
Okay, so you can use one of these boards like a master and the others as a slave. For example, with E2C. Okay. So for the networking exercise,
Now, how fast did you run the I2C? What's the data rate?
sorry.
What is the data rate for the
Ah,
I2C?
I think it was 9600 the baud rate. Okay,
Oh,
it's you
let's
can
see.
see you can read about the sketch the program I use later.
Okay.
If you scroll
We
down the page. Okay.
let's see. I'm going to take a minute. Uh, we lost my desktop again. This is going to be IT challenge because it's all through a telephone. I'm getting the desktop back in. Um, so let me just. I've got my desktop back up. Let me get it back in the conference. So the Okay, my desktop's back in. Good. So the reason I'm asking is I2C it's synchronous and the standard's fairly conservative. You can run it faster than a megabit.
Okay.
Um, so uh, there's a couple different specs for I2C, but because it's synchronous, you just need both sides to agree. And so again, you can run I2C, faster than a megabit to get much faster data rate between your cores.
Okay. Okay, I will try to use faster bandwidth.
Yeah.
If you can see, this is the modular satshakit blinking together.
Okay.
Okay.
Oh, a little closer to the camera. I didn't. Do that again.
Yes.
Okay, now I see it. Yeah. Okay, that's great. Okay, so now keep going. It looks like you've turned it into something bigger.
Yes, because I wanted to implement a full Internet of Things system. This is a general and high level schema. And at a low level, you can find the Sasha kits connected by 2C or with the Wi-Fi module, the ASP8266 module. And
So
also,
pause on that. How did you do the ESP8266? Is that as a Arduino peripheral?
yes, I used the Arduino libraries for E2C, and
Okay.
to communicate with the Wi-Fi module, I used the serial library. Okay.
Okay.
Okay, and the modules, the Wi-Fi modules can do a HTTP GET request to a web server. I used Jetty as a web server on my notebook. And this web
Go
server,
a little slower. Why did you use Jetty?
yes, because I worked with Jet in the past, so I know how to set up this web server, and
Okay.
also it's very light as a web server. So if you
Okay.
need a light web server to use to do some tests, it's okay. And
Okay.
this web server acts like a gateway. So this gateway will send data to a more smart system, a remote system that is an instance of practical resonance system. That is a framework that I developed at Engineering Informatica. It's a multiple agent system that acts like with the BDI model of agency and the Michael Bratman theory and so on. So it has every agent has an inside representation of the world. This is made by a belief base that is wrote in Prolog-like language. And this is a little example of some sample rules that you can implement. Basically, is basically logic rules. Okay. So okay.
Interesting.
Here you can see the code for for one IoT. No, this is okay. The code of the fractionist, the fraction practical reasoning system. Okay, this is the code for one of the IoT module. So basically, I check the presence, the pin connected to the PIR sensor, and then when there is a status change, I will send a HTTP GET request to the JT web server. Okay, this is the part, one of the principal classes for JT web server. So you can see here that is also a REST client that will send a request to the practical resonance system. Okay.
So this is almost a final project. If you do a nice job of packaging and
Okay.
design nice enclosures, this is very close to a final project.
Okay. I also seen that the battery not lasted so much because the Wi-Fi module power consumption is very high. Also, I made one of these IoT module with the modular satshakit. So I used one satshakit to send data with the Wi-Fi module and another satshakit to read the sensor value. And this is done by the E2C, as we talked just before. This is the slave, okay? And this is the first test. Just it's me that I would get closer to the module, and you can see that the LED is powering on. That is
Yeah.
detecting my presence. And this is the video about the full test. So I tested it.
Now, sorry, a question. Are you using the standard command set in the ESP8266?
Yes. Yes,
Okay.
I have not modified the firmware, just the stock firmware.
Oh, so let me stop for an important thing. The ESP8266, let me get into its command set. There are many different firmwares for it, but just with the standard firmware, you can use it to do HTTP,
yes.
which rides over TCP. But there's two things you can do that are more efficient. One is you can just do web sockets where you do TCP and you open a connection and you leave it open. HTTP has to make and break the connection every time.
Yes.
And TCP needs three packets, SYN, SYN-ACK, and ACK, every time you communicate. So better than HTTP is you open TCP and leave it open. But even better than that, the ESP8266 can do UDP, which is connectionless, where you just send or receive a packet and you don't have to make a connection. And those are much less overhead and they're much more reliable.
I used the HTTP protocol because the lack of the time I had to implement.
No, I understand, but for the future, to make it more robust, it's better to do with web sockets. You can talk a layer down. Yeah.
Okay, so this is the video.
Can I add something to that?
Okay. Please, Fiore, go ahead.
Yeah. So there is a variant of HTTP which is called CHTTP, which is dedicated like for Internet of Things devices.
Only two one for you, is it?
Sorry?
What they call?
Sorry, there's somebody who's not muted. Boss, can you figure out who that is?
Okay. And so one thing is this one. So there is this variant of HTTP which is more compact. And
Yep.
so it's optimized for these small devices.
Yeah.
And another one is that through UDP, you don't have to invent your own protocol, but you can write over...
Sorry, say that again, Fiore.
So via UDP, on UDP, you don't have to write your own protocol. You can use OSC.
So we have a dog visiting, and the two dogs. So in addition to having no power, we have two dogs negotiating and announcing their presence. It's very busy in Cambridge.
Okay, nice.
So, okay, so go ahead for UDP. What were you saying, Fiore?